All right, let's get our attention up front. Eyes up here, please. Let's quiet down. Let's get our attention up front. Eyes up here. All right. So let's go ahead and start going through our materials here. So first we have a little bit of review from what we talked about in Module 3, right? We have dissociation, right? So dissociation is a process when things that go into water break into different parts, right? So when we talked about this all the way back in like Module 3, we said like if we dissolve NaCl in water, it splits up into Na plus and Cl minus. Do y'all remember that so far? Okay. Now today when we're talking about it, we're going to be talking about acids or bases breaking up to make different things, all right? Now the other review that we have to have is ions. So remember, ions are just charged particles that are stabilized in water because of their polarity, right? We can have a positive ion or a negative ion dissolve in water because we have the positive side of water attract to the negative side of the ion, or vice versa. Does that make sense so far? All right, questions at this point? All right, let's go ahead and continue. So now let's talk about acids and bases. So an acid is just some chemical that dissociates, and the cation that it makes is a hydrogen ion. So anything that breaks up to make an H plus is an acid. So for example here, if I have HCl, when I put that into water, it will make H plus and Cl minus. And because it makes H plus, it's an acid. Questions so far? All right. Now for a base is any compound that dissociates and forms OH minus or hydroxide ions. So this thing here, OH minus, is called a hydroxide ion. All right. So any chemical that dissolves and makes OH minus is a base. So for example, if I dissolve NaOH, I make Na plus and OH minus. That means that NaOH is a base. All right, questions so far? All right. Now, in a neutral substance, so if something is considered neutral as far as pH or acid and base, that just means it has an equal amount of both H plus and OH minus. If I have more H plus, it's acidic. If I have more OH minus, it's basic. Questions on this so far? All right, let's go ahead and continue. So based on these definitions, I just want you all to look at this list of chemicals and decide whether you think each one is an acid or a base. Now, as you're trying to figure it out, try and remember that humans wrote these, right? So humans decided to write this as HNO3, not NOHO2. They decided to write this one as LiOH, not HLiO. So try and think about what this formula means as far as what type of chemical it is. Is it an acid or a base? Okay? Go ahead, try and identify. See if you can do it. All right, let's go ahead and go over our answer here. So something hopefully you noticed as you were looking around at each of these is that some of these chemicals start with an H. And other ones have an OH in them. So the ones that start with H, what do you think those are? Acid or base? Acid, right? So this is an acid, this is an acid, and this is an acid. So remember, chemists made these formulas. We decided that when we write the formula of an acid, we're going to start the formula with an H so that it reminds us that this is an acid because acids make H+. Does that make sense so far? Yeah? All right. Now for bases, we decided that when we write a base, because bases make OH minus, we're going to put OH somewhere in the formula. So then this is a base because it says LiOH and BaOH2. Right? So these are both bases. All right? So just based on the formula, we can figure out whether it's an acid or base. If it starts with an H, it's probably an acid. If it has an OH in it, it's probably a base. Now I say probably there because this is a simplified definition, right? If you go on into higher levels of chemistry, there are other chemicals that will have OH in them or start with H that aren't necessarily acids or bases. But for our class, if you're trying to just identify something as an acid or base, if it starts with an H, it's an acid. If it has an OH in it, it's a base. Questions so far? All right. So now let's talk about what will happen when these dissociate, okay? So when we do this, I'm going to do two of these for you, one acid and one base, and then you are going to do the other ones. All right? So we're going to start here with H2CO3. Now, just based on the formula, is this an acid or is it a base? Acid. Okay? So we know that acids make H+. So when I write out our reaction here, I'm first just going to draw an arrow. Right? So H2CO3 is going to turn into an H+. And if I remove a single H+ from H2CO3, I just need to write what's left over, right? So if I start with H2CO3 and I remove an H, then what's left over will just be HCO3. Right? If I remove an H from H2CO3, I just have HCO3. Y'all with me so far, yeah? So now let's think about another problem, though. H2CO3 doesn't have a charge. That means that if I add all my products back together, those also shouldn't have a charge. So if this is H+, this should be HCO3 what? Minus, right? So if I take away an H+ from H2CO3, I'm removing one H and also one plus. Then I have HCO3 minus as my other product. Does this make sense so far? So I just split H2CO3 into an H+, and then whatever's left over. Okay? Questions at this point? Okay. Now, before we move on, I want to show you a second way that you could write this answer. Now, all we said before was that acids release H+. You could also write this and say that it releases two H+, because it says H2 in the front. So that means there's two H's that could be released, right? Now, if we release two H+, then what we're left with is just CO3. And if we made two positives, then shouldn't we have two negatives as well? Yeah? So if we released two H+, then we'd have CO3 minus 2. Questions on this so far? All right. So we had two correct answers here, right? We could have either put it reacts to make H+ and HCO3 minus, or it makes two H+ and CO3 minus 2. Okay, now let's take a look at the base. All right. So for barium hydroxide, BaOH2, this one is slightly different. With bases, you have to make all of the OH minuses dissociate. You can't just do one or the other like we did with the acids. So on this one, it's a base. So I know I'm going to make OH minus. Now, based on my chemical formula, there's a 2 right here. So I'm probably going to make 2 OH minuses. So I'm going to put a 2 in front of OH minus. Okay. Now, let's talk about a mistake that a lot of students make for a second. Definition of a base is it makes OH minus. Does a base make OH minus parentheses 2? Does it make this? Is that the definition of a base? No, right? We said it makes OH minus. Now, what we're saying when we write a 2 in front of it like this is it makes 2 OH minuses. Bases can make multiple OH minuses, right, as long as it makes OH minus. We will not ever have something where it makes OH parentheses 2. Same goes up here. You would not write it makes H plus 2. That wouldn't be correct because that's a different chemical, right? It either makes H plus or multiple of them, or OH minus or multiple of them. Okay? Now we just need to write out the other part. So if I separate off 2 OH minuses from BaOH2, the OHs are gone. So I'm just left with Ba. Now let's think about the charge. BaOH2 is neutral. We have 2 negatives. So what should the charge on Ba be? positive what? Positive 2. Okay. So I put Ba plus 2 plus 2 OH minus. All right, questions so far? All good? Okay, so I want you all to try and fill out the rest of the chart here. So try and write out the dissociations for HNO3, LiOH, and H3PO4. Go ahead and try this out. See if you can do it. So starting with HNO3, we can tell that this one's an acid because it starts with an H+. So because we have an acid, we know we're going to make H+, and we're also going to make NO3-. That's what's left over. But if we remove an H from this, we're left with NO3. Because the H is positive, the NO3 must be negative. Okay? If you go to the next one, LiOH, because it has an OH in it, we know we're going to make a base. So we know we're making OH-. If we remove an OH- from LiOH, we're just left with Li. So then, because it has a negative charge here, Li must be positive. So we have Li+. Question so far? All right. If we go on to the last one with H3PO4, we have a couple different possible answers. You could put that we make H+ and H2PO4-. That's one acceptable way to write this. You could also say that two H+'s separate off. And so then you're left with HPO4 - 2. So this would be acceptable. Or you could say that all three H+'s separate off, and you have 3 H+ and PO4 - 3. So any of those would be acceptable answers for H3PO4. Doesn't matter which one you put. All right, questions on any of them that we've gone over? All good? All right. Let's go ahead and keep moving on then and talk about pH. Now, during yesterday's lab, y'all got to see the pH scale, right? You got to use pH paper and measure out the pH of different substances, all right? Now, pH just stands for potential hydrogen. In basics, it's measuring the amount of hydrogen present in a solution. Now, specifically, it's measuring the amount of H+ in a solution, right? So if a solution has a lot of H+, that'll have a different pH than a solution that has a little bit of H+. Now, the equation that we use to calculate this is that the pH is equal to negative log of H+. Now, if you are coming from math class where you've learned about logarithms and you hate them and you think they're complex and really difficult, that's fine. In this class, why are we talking? What's going on? In this class, what you're required to know, where is the negative button on your calculator? Where is the logarithm button on your calculator? And then able to plug in H+. That is it. You don't need to be able to do math with logarithms. All you need to be able to do is just press buttons on your calculator. Does that make sense? All right. So if we have the concentration of H+, we just take the negative log of it in our calculator. All right. Now, the reason why we do this is in pure water, the concentration of H+ is 0.000001. Okay? So chemists didn't want to write all that out, so we decided to use math, and we found that if we use a negative log, we end up getting a positive number that's somewhere between 0 and 14 anytime we take a pH equation. So it just made the math easier and the writing easier for chemists. But it's just telling us the concentration of H+. Now, the only thing that's weird is because of this mathematical operation, when pH is low, like around 0, that means the concentration of H+ is really high. All right? When the pH is high, at like 14, that means the concentration of H+ is really low. Now, this is kind of the reverse of what you'd expect, right? When pH is low, H+ is high. When pH is high, H+ is low. You got to remember that in your head, that it's a flipped scale. Does that make sense so far? Okay. So now let's do some practice of, or let's visualize that for a second, right? So what this is showing, we have the pH on the left, we have the number for the concentration of H plus on the right here, and then a visual representing that, right? The concentration of H plus is much higher when the pH is 0 than when the pH is high. Questions on this so far? All right. So now let's talk about how we can relate pH to acids or bases. So what we're saying up here, if the pH is between 0 and anything less than 7, that'd be acidic. At 7 is neutral, and above 7 is alkaline. Now, alkaline is another word for basic, right? That comes from a history of chemistry that you don't need to worry about. But if you see the word alkaline, it just means the same thing as basic, okay? So now I want you all just to fill in this chart. When pH is equal to 7, what is that? Acidic, basic, or neutral? When pH is greater than 7, what is that? Acidic, basic, or neutral? And lastly, when pH is less than 7, what is that? pH is acidic, basic, or neutral. Go ahead and fill that out, please. All right, let's get our attention back up front. Eyes up here, please. All right, let's go ahead and go through this one. So if pH is at 7, that means it is neutral. If pH is greater than 7, that would mean that we have a basic solution. And if pH is less than 7, that means we have an acidic solution. All right, questions on this so far? All right. So now let's go ahead and go through this part here. So this is just a sample calculation. I'm going to do this one and show you, and then you're going to do the next one on your own to see if you can do it, okay? So this one says a hydrochloric acid solution has a hydrogen ion concentration of 10 to the negative 1 molarity. What's the pH? All right. Now remember, the equation is that pH equals negative log of the concentration of H plus. So then, since the problem tells me that the concentration of H plus is 10 to the negative 1 molarity, then I'm just going to do the negative log of 10 to the negative 1. And so I can plug that in my calculator. When I do negative log of 10 to the negative 1, I end up getting that my pH is just 1. So I want you all to try that and make sure you can do it on your calculator. Make sure if you plug this into your calculator, you get a value of 1. Now this problem is mathematically easy. I know that. But I'm just trying to check to make sure that your calculator matches what it should say. Go ahead and try this out. Make sure you get it. If you don't, call me over. So go ahead and make that change. Change this to 5 times 10 to the negative 13 for the next problem. And try and solve this one. So you're doing the same thing. Just try and solve 5 times 10 to the negative 13. What would the pH be? Go ahead, try and solve. So on this one, we changed it. The problem originally just said the concentration is 10 to the negative 13. But remember, we changed it. We said it's 5 times 10 to the negative 13. Just to make the problem slightly more challenging, okay? So if we have 5 times 10 to the negative 13, I'm just going to do negative log of 5 times 10 to the negative 13, plug that in my calculator, and what I get is 12.30. So this is what you should have gotten when you plug this in, 12.30. Okay? Questions on this one? All good? Okay. If you're still struggling with plugging into your calculator, make sure you call me over because that should be an easy problem on your test, right? You're just taking the value you're given, you plug it in, and you solve. If you are struggling with your calculator, though, call me over so we can help you remove that barrier and make sure you get that easy point. Sound good? Someone's out right now. Or for a charger?
Yeah.
All right.
Thank you.
Oops, sorry. Go ahead. All right. Let's go ahead and keep going through. Let's quiet down, please. All right. So next, let's talk about the effect that increasing carbon dioxide in the atmosphere that we learned about in Module 7 has on the ocean. Okay. So we know that atmospheric carbon dioxide has been going up. That's this yellow line here. Okay. Now, this pink line is showing that because the concentration of carbon dioxide has been going up in the atmosphere, that is also causing the concentration of carbon dioxide to go up in the ocean. So we measured that it went up in the atmosphere. That is also affecting the ocean. Does anyone remember what carbon transfer process causes the ocean's carbon dioxide concentration to go up? Anyone remember? So what carbon transfer process causes carbon dioxide to go into the ocean? Yeah. Not chemical weathering. Yeah. Ocean-atmosphere exchange, right? So an ocean-atmosphere exchange, it just means that every time there's a wave that crashes, that means water and air are interacting. If there's more carbon dioxide in the air, more will get into the ocean, right? So then what this green line is showing is that we've also tracked the pH of the ocean. And as the concentration of carbon dioxide went up in the ocean, the pH of the ocean went down. Okay? This is also what you saw yesterday during your lab. Let's quiet down. When you increase the concentration of CO2 by reacting baking soda and vinegar, the concentration of CO2 went up in your container, which then caused the pH of your ocean to drop, right? It went from blue to yellow, all right? So what we can show here is that because we've increased CO2 in the atmosphere, almost 30% of that carbon dioxide has gone into the ocean, and that has caused the pH of the ocean to drop. Now let's take a look at why. So if we look at this reaction here, carbon dioxide can react with water to make this chemical here, H2CO3. Now based on the formula, what type of chemical is this? Acid or base? Acid, it starts with an H, right? So because it starts with an H, this can then dissociate to make H plus and HCO3 minus. So we've increased the concentration of H plus. Because we increased the concentration of H plus, that means we're going to have a lower pH, right? Higher concentration of H plus means lower pH. So that's described down here. When carbon dioxide combines with ocean water, it creates carbonic acid, that's H2CO3, and carbonic acid can dissociate to make bicarbonate and free H+, free hydrogen ions, which means the pH gets lower. Questions? All right. So now what I want you to answer here, if the pH drops, if the pH gets lower, which ion is increasing? So the question is asking if we lower the pH, which ion has its concentration going up? So go ahead, talk to people at your table, try and decide. If the pH goes down, the concentration of which one of these is going up? Talk to people at your table and decide. All right. So remember, pH just measures the amount of H+. It doesn't measure anything else. So that means that if we see a drop in pH, that means that H+ is going up, and that's it. The reason we're going over this is in your lab, you're going to be asked to explain, why did the pH go up? Why did the pH go down? What changed? What is the only thing that changes when you change pH? H+, right? So anytime you explain a change in pH, you need to explain how H+ is affected. Now, in the example that you did during your lab, you made a change to the amount of carbon dioxide. And because you changed carbon dioxide, that made carbonic acid. Did the carbonic acid change the pH? No. The H+ that the carbonic acid made changed the pH. That's a distinction that's small but important, right? pH only measures H+. It doesn't measure the amount of acid. So even if there's more acid present, that doesn't mean pH will go down unless that acid also makes H+. So make sure you include that in your explanations. So the last question here was just to remind you that if you're explaining pH, if you're talking about a change in pH, you have to explain it in terms of the change in H+. All right, questions here? All good? All right.